So this is about Kolbe reaction, and in Kolbe reaction salicylic acid you will get as the product. And what is the use of salicylic acid? When salicylic acid, this is not the part of Kolbe reaction. Kolbe reaction is only this one. So this is just for use of salicylic acid. This is very important. When salicylic acid reacts with acyl chloride or ethanoyl chloride, which is also used in Friedel-Crafts reaction, then it produces a compound COH will be present here. This hydrogen combines with this chlorine, they will make HCl, and this part combine with oxygen and it becomes OCOCH3. Side product will be HCl. This compound is called aspirin, which is a popular painkiller. So to prepare aspirin, salicylic acid is used. And if you want to know about the IPAC name of this, you can write 2-acetoxy-benzoic acid. In exam, this question may be asked, what is the IPAC name of aspirin? Then you have to write 2-acetoxy-benzoic acid. This is the IPAC name. So this is about the Kolbe reaction. In Kolbe reaction, when phenol reacts with carbon dioxide in presence of alkali, it produces salicylic acid. And salicylic acid has one use. You can prepare a popular painkiller called aspirin from this salicylic acid compound. Now another reaction, and this reaction is the most important reaction from phenol. From phenol, if some question asks, you will get this reaction. 99% probability of this reaction, which is called rhematin reaction, the most important reaction from phenol. Rhematin reaction. What about the reaction when phenol reacts with chloroform CHCl3 and alkali sodium hydroxide? Then first time it produces salt. The salt is like this. Here aldehyde group will be present, and when you do hydrolysis of it, then ONA will be converted to OH, and here CHO will be present. I mean, this is one example of aldehyde, and the name of this aldehyde is salicylic. So this is about the rhematin reaction. When phenol reacts with chloroform and sodium hydroxide, then first time it produces salt. After that, when you do hydrolysis, it will convert to salicylic. So what is the difference between Kolbe and rhematin? In Kolbe reaction, the product was called salicylic acid, and in rhematin reaction, the product is called salicylic. In Kolbe reaction, we use carbon dioxide as reagent, and in rhematin, you have to use chloroform as reagent, and both the reaction contain alkali, I mean sodium hydroxide. And if you want to know about the mechanism of this reaction, how the reaction takes place, this is one of the electrophilic substitution reaction. So the mechanism will be electrophilic substitution reaction mechanism, but the mechanism is something different. So that is why I will give you about this. First time, step 1, production of electrophile. Production of electrophile. Our reagent is chloroform CHCl3. When it combines with the base sodium hydroxide, the OH minus ion take one proton from this, and it goes to, proton means the H plus ion will combine with OH, it produce water, and it produce CCl3, one anion it will produce, water is released from it. This is unstable, that is why it again break, and it produce one chlorine will be released from it, HCl minus, carbon contain one lone pair, and this is called carbene, and this will act as electrophile. Lone pair is present, but it acts as electrophile because electron deficiency is present inside carbon. Carbon contains 6 electron here, and that is why 2 bond, 1 lone pair, 6 electron present, that's why it acts as electrophile. And in exam the question asks, in rhematin reaction what is the name of electrophile? Then you have to write carbene. One more question. Now in step 2, the electrophile will attack, that's why the step is called electrophilic attack. Production of electrophilic attack. So due to presence of base, phenol produce salt O minus, because you know phenol is acid. Acid when combines with base always it produce salt. That's why I have written like this, ONA. When it combines with the carbene, I mean the electrophile, this double bond will take the carbene. After taking the carbene, double bond will break. Actually this lone pair, first time it will come here, it produce double bond, then this double bond break and it will take the carbene. Then with oxygen it become double bond. This double bond remains same. The CCl2 will join here. Here hydrogen is joined. One lone pair is present here, that's why it becomes negative. Again, this bond will shift from this to this, and the hydrogen will be H plus will be joined with this negative. Ultimately, you will get here double bond, here double bond, here double bond, and this will shift to here. O will be negative due to presence of 3 lone pair now. Here 2 lone pair present. Oxygen always have 2 lone pair, and this become CHCl2. The hydrogen will be joined with the carbene. After getting this, when you apply sodium hydroxide, then it will convert it to salicylic. If you do not understand about this step, then I can show you here how it produce. When this compound reacts with sodium hydroxide, the OH minus ion replace the chlorine. Here twice NH means both the chlorine will be replaced by OH, and that is why first time it produce like this CHOH2. I mean both the chlorine replaced by OH, and this OH2 they will be present like this OH. When a carbon contain 2 OH group, then it become unstable. That's why this one will come from this to this, it become double bond, and this bond will completely break. I mean hydrogen H plus ion is released from it, OH minus is released from it, they produce water, and the compound goes to like this O minus, it becomes CHO, and water is released from it. So like this way the salicylic is produced. So this is about the mechanism of Raymer-Tiemann reaction, and the mechanism is very important for exam. Have you got the mechanism? When you draw the mechanism, first time you look the mechanism how I have drawn, after that you try to do it, and when you draw the mechanism you have to show the arrow like this, then you will get the marks, and always you write in step by step. This is one of the important mechanism for your exam. Okay, thank you for today.